Hello everyone, today we will do one more practical of class 12, which is to find out the focal length of convex lens using UV method or double field method or no parallax method. So all are same, no parallax, UV, double field, so both are same. So let's start the experiment. So first we will check what instruments are required to do this experiment. So first see, this is optical bench and these are the three holders. This is for object pin and this one for the lens. This is the lens holder and this one is for image pin. To start the experiment we need the convex lens and first we have to measure the rough focal length of the lens. How to measure? You will project the image of light on the table where it will come clear that position you will measure it. Okay, so I am getting it is 10. Now come over here, you place the object pin at 0 mark, then put this lens inside the lens holder, make it tight, then place the lens at more than 2f. 2f means here we got the rough focal length is 10, so the more than 2f I am starting from 25 because 2f is 20, so more than 2f 25. So if in your question it is given 25, so you will start from 25. If in your question it is given start from 30, so you will start from 30. If it is not given, you will start from more than 2f. Okay. First, place the lens at 2f and object position will be fixed. 25 I have placed. Now I will remove the parallax. What is parallax is? Parallax is when you will see the image through this lens, you will get one inverted image. Okay, the image will be like this. Image will be, it is like this. Okay, and by changing the position of the lens, position of the image pin, what you have to do? First, you will match tip to tip. Tip means tip of the image pin which will be seen through this lens and this tip of the image pin. It will be like this. Okay. And see from a certain distance, then you will move your head like this. Then if they moves like this, then your answer is okay. Okay, means parallax is what? First you match tip to tip, then you move your head left and right, then check the image and the image of the object pin, they are moving straight or not. If they are moving like this, then there is parallax. So that you have to remove. Okay. So how to remove this parallax? You have to change this position of the image pin. So first reading I am taking. So already the image came over here. So let me increase the object length. Okay, now it is okay. Now that reading I will show it. Done. So if I move my head, then this image of the object pin and this image pin, they are moving together. Okay, so they means the parallax is being removed. Now you see how this parallax is being removed. See the image, if you see through this lens, then and the image pin, this one, they are moving together when I am moving my head towards left or towards right. Understood? So this is how you have to remove the parallax. So this is the first reading. Here I got the position of the lens is 25, this one, and the position of the image is near about 41, 42, 43.2. Okay, so these two readings I will take. After this, you have to change the position of the lens by 10 centimeter or 5 centimeter. That will be given in your questions. Suppose it is giving change the position of the lens by 10 centimeter, then the next readings you have to take at 35 centimeter. Means the position of the lens will be 35 and you have to remove the parallax by changing the position of the image pin. That second reading I am doing and I will show it. Now it is done. So let's check. This is the second reading at the position of 35, means the lens position. The image of the object pin and the image pin, they are moving together. I hope you have understood. This is how you have to take the readings for 45, 55 and 65. And this is the reading for lens position 25, 35, 45, 55 and 65, and the corresponding value of UV and XY. So by taking these X and Y values, we will draw the graph. So let's see how to draw the graph. Now I am going to plot the graph of UV method. First I will take X axis and Y axis. Done. This is X axis and this one is Y axis. Now this value I will put it in the graph paper, so you can check this X value and Y value. First value was, I hope you have taken that screenshot. So first value of X and Y is given 0.8 and 1.1. so that is the value I have to convert into division. So how to plot the graph of double field method? First you check in the X axis, the highest division is how much? 0.8. okay, so along X division 0.8 I will take. So if I take 0.1, 10 division equals to 0.1, then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. so up to this we can plot it. So remember, at least 70 or 80% portion you have to fill up. And in this double field method, remember this, along the when we are going to plot along the Y axis, you have to give some gap over there, because the graph will come like this. So it will touch at the Y axis, that you have to measure. So if you didn't give the gap over here, then this graph can cross this line. Okay, so now see, I am going to plot the value of Y axis, whose highest value is 1.6. So 1.6 means here I will take 1.6 to 0.2, 10 division equals to I am taking. First you check 0.2, 0.4, 6, 8, 10, 2, 4, 6. No. So I have to take 0.5, 20 division equals to 0.5. That will be better. Okay. Then this is 1, this is 1.5 and this one is 2. Now it is okay. 20 division I took 0.5. Okay. So 0.5 is 20 division. After this 1, then 1.5 and then 2. Now you have to measure the one smallest scale division along x-axis and along y-axis. Okay. First you write along x-axis the one small scale division equals to, see, along x-axis what I took, 10 division equals to 0.1. Okay, so 1 division equals to how much? 0.1 by 10 equals to 0.01. Okay, now same way in the y-axis, one small scale division equals to what I took, 20 division equals to 0.5. Okay, so 1 division equals to 0.5 divided by 20. So it will come 0.5 by 20, you do it. Then it is coming 0.025. Okay, 0.025. So this is the one small scale division, means this one, 1, 2, 3. Say one scale division is 0.01 along x-axis and 0.025 is along y-axis. Okay, now I am going to plot. How to plot? See, the first you observe the x-axis is, along x-axis it is 0.8 and along y-axis it is 1.1. So that is value. I have to convert into division. What you will do? That 0.8 divided by one small scale division along x-axis, because I am going to plot along y-axis, along x-axis. So 0.8 divided by 0.1. How much it is coming? 0.8 divided by 0.01. It is coming 80. So how you will put it? 80 along x-axis. So 10 up to this 10. 10, 20, 30, 40, 50, 60, 70 and this is 80. Okay. This is 80. Now along y axis how much reading is there? 1.1. So 1.1 divided by 1 smallest scale division along y axis was how much? 0.025. 0.025. So it is coming 44. So from here we will move up to 44. 10, 20, 30, 40, 44. This is the first reading. This is how you have to plot all the readings. Second, I am showing 0.6 is there. This is 0.6 divided by how much? You tell. 0.6 divided by 0.01. So this is 60 is coming. 60 means 10, 20, 30, 40, 50, 60 up to this. And y-axis value is 1.3. So 1.3 divided by 0.025. So it is coming 52. So from here it is 52. 10, 20, 30, 40, 50, 52 is this point. So this is how we will plot all the 5 readings. Okay. Now you check all the 5 values I have given over here. I have counted and I have plotted, and then we will draw the graph. Remember, this at least 3 points should match, and I got the rough focal length which is 10. So this y naught value should come how much? This y naught value should come, it is near about 2. Near about 2. Okay, so that you have to keep it in your mind. So that is how I am drawing this. So it is maximum line, it is touching. Okay, and you extend it. Okay, now it is touching over here. Here it is touching. Okay, this value is called y naught. And how to find out the value of y naught? Y naught equals to, look, this point has crossed the 1.5. Okay, so it is 1.5 plus, that's a value I am calculating over here. Now see, 1.5 plus, how many divisions are there? 10, 11, 12, 13, 14, 15, 16, 17 is there. So after 1.5, it is 17. So y naught value it is 1.5 plus 17 into, along y axis the smallest scale division was 0.025. So that value you have to calculate. It is coming 1.5 plus 17 into 0.025. So this is 0.425 plus 1.5. It is coming 1.92 or 925. Okay. Now how to find out the focal length? F equals to 20 by I naught. So 20 divided by 1.925. It is coming 20 by 1.925. It is coming in near about 10.3. Okay, centimeter. So this is the ultimate answer. I have understood this graph. Thank you.